Hi everyone and welcome to a new video. Today I'm showing you how I finished my challenge, my 24-hour challenge to create Minecraft. The actual coding time that I spent coding was 5 hours, because in between I actually had to go to university and sleep. So I just sat down one evening and told myself I'm going to create Minecraft in 24 hours. So I was fixed to that time frame, but the time that I had to code was only 5 hours. But in that time, I basically created a basic Voxel Engine. So I did have the infinite terrain and procedurally generated, as you can see at the end then. But what I'm doing right here is I'm creating the block. I'm creating the code for the block. And as you may know that in Minecraft, for example, what you see is not actual blocks, but it's only some sides of them. Because you don't render what the player can see, because that would be wasted resources. So I can't just take like the predefined block in Unity. Like there's a cube prefab that you can use, but I can't use that because it renders everything and I don't need that. If you look at one chunk, or if you look at a normal 16 by 16 by 16 chunk, if it would be floating in the air, all I have to render is every side of the chunk, but all of the sides that the cubes that are inside the chunk, I don't need to render the sides of the cube that are inside the chunk, because the player won't be able to see them. So that would waste a shit ton of resources. So I'm basically coding the math behind this one. So I'm creating the blocks by myself. I create the positions in 3D space and connect them with 2 triangles per side, and I map the textures via UV mapping onto them. And then I look at each block individually, and I look at all the directions the block is facing, so up, down, north, south, west, east, whatever, and I see is it blocked by another block, and is that block solid? If so, don't render that face, and if it's not, then render that face or that side. And that's basically the math behind one of those pseudo blocks. So right here, I think I'm starting to code the chunks and the world generation. But right now, I'm just hard coding some form of chunks that I'm gonna render, because right now I don't have the infinite terrain yet, and I need to check how my chunks are actually loading. And one of the first things that I did was make the chunks savable. So if you edit a chunk and then move out and delete it and reload it, there's actually a save file on your computer that saves it. Now the first problem that I have with that is that I just took the entire fucking chunk and saved all of the blocks inside it. So that's 56 kilobytes per block, per chunk. That would be, first of all, a lot of space needed on your computer for all the chunks, and second of all, it terribly slows down loading. So what I ended up doing, as you can see here, I'm testing the chunks right now and the loading and saving. So what I ended up doing is I know the position of the chunk, and then know the position that the chunk had in the noise that I'm later going to use for generation. So I can just completely create the chunk again as if it was the first time. And then all I save is the blocks that have been updated inside the chunk. So if I place a block or delete a block, the block will be saved as an updated block. And so in a chunk, I only need to save a couple of blocks that I have updated or like the player has changed. Thus, the actual size of the individual chunk files that I save is only around 5 to 10 kilobytes, if even. And so that speeds up saving time, that speeds up loading time, and it basically just speeds up everything, and that's cool. There's like a lot of idle that you see in the video. It's when I basically Google for shit, and but yeah, I can use this for some extra info. But yeah, what I ended up using for infinite terrain generation is basically simplex noise instead of Perlin noise, as Perlin noise is 2D, and for ease of use, I just ended up using simplex noise as it is a 3D noise. And right here you can see me actually I'm coding the generation right now. And what I do is I just take the simplex noise and I generate the chunks by columns using some variables that I set up to use, and yeah, basically randomizing where the blocks are generated in a column in a chunk, which then ends up in some nice hills and valleys and shit. It's not as refined as Minecraft, of course, as it's just, look at that, it's like 30 lines of code. But here you can see the first couple of chunks. So the problem was that I had chunk loading, but I didn't I totally forgot that I have to delete them as well, because if you fly away far away, and you don't delete the chunks that are way back, it fills up memory and it begins to terribly lag, because it also gets rendered by the graphics card all the fucking time. So what I ended up doing is write a little bit of code. It just checks nearby the player. I'm actually writing it right now here, load chunks, so that it looks around the player and generates the chunks around the player and prioritizing the ones closest to the player. And after that, he also checks all 10 frames, I think. I check around the player again. If there are chunks that have a distance that is high enough, they get deleted again. So the deletion process is basically saving the chunk to a file if any blocks inside the chunk have been updated, and then removing it as a game object from Unity. So freeing up the RAM, basically. And you can see that working right here. I think I didn't have the delete chunks yet. Yeah, I'm coding that right now. So that actually ended up working like perfectly. I was kind of surprised. I'm importing the FPS controller right now because I didn't want to waste any time in coding a proper first-person controller. So I just implemented the one that I got from Unity. It's a standard asset. It's pretty neat. It has some nice bunny hop mechanics. So I think that I did is I coded this entire thing on my laptop. And the reason for that is that, first of all, I could take it with me to university and code there. And second of all, that I could also test if the shit that I'm writing is efficient, as it should be running on my laptop and not on my computer, because the computer is way more powerful, so it basically doesn't show me how much I'm fucking up. Now I'm setting up some lighting stuff, because I noticed that the blocks are really shiny, like as if they're metal, and that was kind of weird. So I changed a bit of the terrain and the sprites and shit. What I did right now before is I did some custom code for getting the hash and also comparing to world positions, which made it a lot more efficient, as it is done a lot when generating the terrain. So that sped up the game quite a lot. Now, since none of it, I didn't put world generation and shit like that in separate threads, which would speed up the process by a lot, but I just didn't have the time to go through the entire hassle. So I basically couldn't really solve that problem yet. I'm probably going to keep going on with the engine, as it was a lot of fun writing such a voxel engine. And maybe even do a second part, and I think I probably will completely rewrite the entire engine at some point. If you're interested in that, like coding Minecraft in 1 week or something like that, then just leave it in the comments below. Because I think it should be a lot of fun, because I basically created the entire engine in 5 days. So in 5 hours. So it's gonna be fun seeing what I can do in a week. I just have to balance it with university, as I have university every day. Yeah, I'm kind of getting to an end right now. I'm creating trees, caves right now. My cave system is really primitive. It's basically just like holes inside the terrain. It doesn't look like a cave at all yet, but I didn't have time to really flesh it out. And my tree generation was actually kind of fucked before in the beginning, as the trees weren't complete. Like, the leaves were cut off and shit. And the reason for that was that, as you can see here in the sped up footage, it was kind of fast. You can pause the video. The reason for that is that the leaves expand into different chunks, and the way my chunk generation was going is just inside one chunk. I didn't have the capabilities of moving into another chunk. So I had to make it possible that trees generation can go beyond just one chunk, but to 2 or 3 chunks, and that fixed the problem with the leaves. You can also see the holes in the terrain that should resemble caves, but it doesn't. But I couldn't manage to do much more in the 5 hours that I had. Um, I don't know what I'm doing right now. I'm just idling. Probably just searching in Stack Overflow, and I saw some interesting posts. Because I for the end I actually wanted to aim at some sort of cube world style, but I didn't know how to do that yet. And you need some strange algorithms that do cube marching or marching. I don't know, and I don't know about that yet. So I have to implement it in the 1 week project. I actually found out I don't have Photoshop on my laptop, so I had to get some crosshair from the internet so that I can see what I do. And the problem I had is, first of all, it wasn't centered first. Like, block deletion and creation was kind of fucked up. So I had to create an empty object and move it in front of the player, so that when, for example, if I want to destroy a block that is below me, I cast a raycast in Unity and see where it collides. And the problem is, when I use the camera as my origin for the raycast, my raycast hits the collider of the player, so that everything's basically fucked up. So what you could see there, that I create a hand that floats in front of me at all times, and that basically fixes the problem. So I hope you enjoyed this project. It was a lot of fun to create, and I see you in the next video. Bye.